Hello, classmates! Basic idea components of circuit diagram include resistors, capacitors, and inductors. In the previous section, we briefly learned about resistors. In this section, let's continue to explore inductance and capacitance. In order to represent effect of current on magnetic field in the current-carrying circuit, we introduce inductive components. Inductors are typically coils made of wires and are elements capable of strong magnetic field energy. When an inductor is energized, a magnetic field is established around it, and the received electric energy converted into magnetic field energy and stored. The main function of an inductor is to establish and store magnetic energy. Inductance is the basic component of a circuit. Its basic working characteristic is to allow the passage of low-frequency signals and to reject high-frequency signals. The magnitude of inductance represents the ability to induce electromotive force. The unit of inductance is Henry. We commonly use units such as millihenry, microhenry, and nanohenry. And the conversion relationship is 1 Henry is equal to 10 cubic millihenry, which is equal to 10 to the power of 6 microhenry, and is equal to 10 to the power of 9 nanohenry. Inductors come in various shapes in real life. The left part of the picture shows the shapes of several kinds of commonly used inductors. The right part of the diagram is the symbol of a typical inductance component. It is often represented by the letter L. The magnitude of inductance for a coil depends on factors such as the shape, geometry, number of turns, and magnetic permeability of the medium used. However, the inherent characteristic of an inductor is its ability to allow DC to pass through while resisting AC. Voltage across an inductor only occurs when there is a change in current flowing through it. Furthermore, the direction of the induced electromotive force is such that it opposes the change in the current. The magnitude of the electromotive force is directly proportional to the inductance and the rate of change of current. In a DC circuit, even if there is a current passing through the inductor, the voltage across it is zero, which is equivalent to a short circuit. Inductors can be connected in series or parallel. The equivalent inductance of series-connected inductors can be expressed as L equals L1 plus L2 plus series plus Ln equals sigma Ln. The equivalent inductance of parallel-connected inductors can be expressed as 1 over L equals 1 over L1 plus 1 over L2 plus series plus 1 over Ln. The magnitude of inductance can be measured by instruments. The no-load measurement steps of inductance are as follows. 1. Familiarize yourself with the operating rules and precautions of the instrument. 2. Turn on the power supply and wait for 15 to 30 minutes for preparation. 3. Select the L gear and choose the amount of inductance to be measured. 4. Clamp the clamps together and reset to 0. 5. Clamp the two ends of the inductor with the two clamps. Read and record data. 6. Repeat steps 4 and 5. Record the measured values. 7. Compare several measured values. If the difference is not significant, take the average. If the difference is significant, repeat steps 2 to 6 until the theoretical value of inductance is obtained. The quality of inductance can also be judged by instrument. For example, the measurement of inductance, turn the multimeter to the buzzer diode. Put the stylus on the two pins. Look at the reading of multimeter to judge good or bad. For the patch inductance, the reading should be 0 at this time. If the multimeter reading is too large, or infinity indicates that the inductance is damaged. For an inductor coil with a large number of turns, if it has a smaller wire diameter, it may appear hot when damaged. Or the inductance magnetic ring may be obviously damaged. If the inductance coil is not seriously damaged and you can't be sure, the inductance can be measured by an inductance meter, or judge by substitution method. When measuring inductance, it is important to take into account the susceptibility of inductive elements, core, and winding to be damaged. Due to the temperature rise effect, it is crucial to pay attention to the body temperature of the element and ensure it falls within the specified operating range. 2. After the current passes through a winding, it is easy to generate an electromagnetic field. When placing components, it is essential to note that inductors should be far away from each other or positioned at right angles to each other to reduce mutual inductance. 3. Gap capacitance will be generated between winding layers, causing bypassing of high-frequency signals and reducing the actual filtering effect of the inductor. 4. When testing the inductance value or Q value with an instrument, for the correctness of the data, the test leads shall be placed as close as possible to the component body. Next, let's learn about capacitance. Capacitor is called capacitance for short. It is one of the most common electronic components. Its letter symbol is C. As the name implies, it is a container for strong electric charges, enabling it to store a certain amount of charge. Despite the variety of capacitor types, their basic structure and principles remain the same. Between two closely spaced pieces of metal separated by an insulating substance, a capacitor is formed. Two pieces of metal are called plates. The insulating substance in the middle is called dielectric. The normal working mode of a capacitor is charging and discharging. The main performance of capacitor in circuit is to establish electric field and store electric energy. The characteristics in the circuit are as follows. It allows the flow of AC current while blocks DC current, allowing high-frequency signals to pass while blocking low-frequency signals. Therefore, it is often used in oscillation circuit, tuning circuit, filter circuit, etc. The capacitance is a parameter that measures the energy stored in a capacitor, represented by C. Obviously, capacitance not only means an electrical component, but also represents a circuit parameter. The capacitance of a capacitor is defined as the amount of charge stored when a DC voltage of 1V is applied to it. Mathematically, the capacitance C is equal to the charge Q divided by the voltage U. The international standard unit of capacitance is farad, denoted as F. The commonly used capacitance is relatively small. Unit conversion is required. 1 farad equals to 10 to the 6th power microfarad equals to 10 to the 9th power nanofarad equals to 10 to the 12th power picofarad. There are many kinds of capacitors in life, and classification methods are also varied. According to their dielectric materials, they can be divided into metallized capacitor, ceramic chip capacitor, polyester capacitor, mica capacitor, air capacitor, paper dielectric capacitor, monolithic capacitor, aluminum electrolytic capacitor, niobium electrolytic capacitor, tantalum electrolytic capacitor, and etc. The basic property of a capacitor is to block direct current while allowing alternating current to pass through. In other words, it presents infinite resistance to direct current, which is equivalent to an open circuit, and its resistance to alternating current is influenced by the AC frequency. Therefore, for the same capacitor, it exhibits different capacitance and impedance at different frequencies of alternating current. Capacitors can be connected in series, also in parallel. The equivalent capacitance of capacitor series can be expressed as 1 over C equals 1 over C sub 1 plus 1 over C sub 2 plus series plus 1 over C sub n. And the equivalent inductance of capacitor's parallel connection can be expressed as C equals C sub 1 plus C sub 2 plus series plus C sub n equals sigma C sub n. A general multimeter does not have a specific setting for measuring capacitance capacity. We can start by measuring the leakage resistance. and estimating the polarity of the electrolytic capacitor in order to estimate the capacitance. This allows us to obtain some relevant characteristics of the capacitor. In reviewing this section, we have gained an understanding of some characteristics of inductance and capacitance. As for the applications, we will analyze and explain it in AC circuit. See you next time.